Right. Good morning, everybody, and welcome to the first quarterly meeting of 2022 of the Drinking Water Source Protection Partnership. I am Ann Spiesman. I am standing in for Rudy Chow, the General Manager of Washington Aqueduct, who is chair of DWSP this year. So thank you all for showing up to this meeting. Great attendance. So glad to see a lot of familiar names and some new ones too. Winter is a good time for us to think about warmer thoughts. We've had some time to consider how nice it will be when warm weather returns. And it's a good time to plan for treatment adjustments that might be needed at water utilities when warmer weather finally does arrive. So once we start thinking about warm weather, though, we think about topics like algae. In fact, 4 years ago at this quarterly meeting in 2018, our DWSP ad hoc algae work group helped us all prepare collectively for the fourth unregulated contaminant monitoring rule, UCMR 4, which required, you may recall, drinking water utilities to monitor for algal toxins, among other contaminants. Let's fast forward to 2022, when we can look back on our most recent summer, the summer of 2021, when the Potomac River's water quality created some treatment challenges for some DWSP utilities. And those treatment challenges may have had something to do with algae, though not necessarily related to algal toxins. We're fortunate today that we've got ICPRB's aquatic ecology experts here to explore this topic with us. Mike Selckmann and Dr. Claire Buchanan. They will help us discuss what algae and primary production can tell us about Potomac River water quality and maybe some possible implications that we can draw for drinking water treatment, and whether better understanding algae can help us with our source protection efforts. So let me introduce our speaker today for the recorded presentation. Our speaker is Gordon, better known as Mike Selckmann, Interstate Commission on the Potomac River Basin employee. He works as the Associate Director of Aquatic Habitats and as an aquatic ecologist. He is the lead investigator for ICPRB's large river, groundwater, and harmful algal bloom programs. Among other goals, his research with the Commission is aimed at identifying and describing the causes and distribution of algal blooms in the Potomac River. So take it away, Mike.
All right, so can everybody hear me? I've unmuted myself.
Yep, we can hear you.
Perfect. And I'm sharing my screen. Is it just the slides? Perfect. All right. So I guess as I get started today, here we go. Sorry, getting rid of all the pop-ups and things. So today I want to talk about the Potomac River, and I guess there were a couple of things that we were sort of asked to discuss, and instead of just being a lecture for 20-21 slides, I hope that we actually have a little bit of discussion, a little bit of communication during this presentation. Algae is a component of the greater picture that is primary production in the Potomac River. And we're going to keep kind of returning to this idea as algae is kind of a subset of primary production throughout. So as we go through today's presentation, I am going to, okay, come on, advance slide. I'm going to kind of break this down into this sort of general concept of the biology and ecology of primary production. What are the key players that we're looking at in the Potomac? I'd like to talk a little bit from, the high altitude view of algae and how it relates to river morphology, kind of considerations on where sediment and nutrients are falling out, the turnover of, how nutrients are basically making their way downstream. I want to talk a little bit about flow, And then finally, I will talk about 2021, but I kind of want to contrast it against basically the historical data that we have, kind of looking at the Potomac and how it relates to algae, to see if 2021 was really a novel year or if it's just kind of an ongoing dynamic thing that was, well, we'll talk about that. So to start, primary production. Well, primary production, most of the Potomac River has filamentous green algae. They have blue-green algae or cyanobacteria, submerged aquatic vegetation, or periphyton. These are generally found in the tributaries, generally shallower systems, clear flowing water. And the main things to consider with this group of primary producers is that all plants need three things. They need water, food, and light, right? So in these systems, generally light is limited by riparian buffer, the width of the stream, things like that. Nutrients are coming from terrestrial environments being introduced, and water, they should have plenty of it. So this is flowing water, and that flowing water is carrying the nutrients to the organism. So these are benthically attached primary producers that are generally found more in the shallower parts of the river. And then we have planktonic algae. Planktonic algae, there's some very high profile examples like what happened a couple years ago in the Ohio River Basin, where microcystis basically looks like this paint spill, and you can see it take up many, many miles, and it's usually related to this, algal toxin issue. But really, when we distill it down, this is just another primary producer in that it's showing up in an environment that is kind of unlike what we see more in the headwaters. It's taking advantage of more stagnant waters, and they're moving vertically in the water column to kind of take advantage of all this light at these larger water bodies. So it kind of brings in the first key concept I kind of want to talk about in this, high altitude view of the Potomac as a whole, is the river continuum concept. And the river continuum concept, in a very brief kind of fly through, is we expect there to be this kind of continuous gradient as we go from smaller water bodies in a tributary down to the largest water bodies. So in this case, we could be talking a headwater trout stream that you could jump over that holds brook trout, and this very gradual, kind of enlargening to something like, say, the Monocacy River, and then the main stem Potomac, then we get down to the Chesapeake Bay. But as we gain river size, we see a shift in this primary production community. So this figure, can you guys see my mouse or?
Yes, we can.
Okay, perfect. So in the headwater, as I mentioned before, things like underwater grass, filamentous algae that are attached and they're staying stationary, they're taking advantage of the clear water. They're taking advantage of environments that are dynamic and flow. And then when we get down to the larger bodies of water, generally just by mass and the shape of the river, we have higher residency time. They're staying, that water, that packet of nutrients and the energy to feed these algae are kind of staying put longer. So it's important to kind of consider where we are in a watershed. What is how is the river acting as a whole? And just something I want to point out, again, the last of sort of the big picture, is if you ever kind of just took a look at the Potomac River as a whole, you'll see that there's a lot of publications on river morphology and what just the shape of the river can tell us. And you'll see highlighted in red And there are these areas that are very sinuous, and there are these areas, and highlighted in yellow are these areas that are much straighter. And generally, these are two different types of depositional areas, but these are areas where as nutrients enter our system, depending on particle size, depending on flow velocity, things like that, things are going to be settling out. But in areas like here at Paw Paw Bends, below Hancock, kind of leading up to the confluence of the main stem Potomac and the Shenandoah, we see these areas that there are a lot of bends, and really this is kind of like driving a car on a road. Every time it hits a bend like this, it sort of it has a slow down. You have to slow as you go around the bend, and that a lot of things are falling out. So in a lot of ways, these areas that are very sinuous are dropping out a lot of the larger sediments. They're sort of acting as a depositional filter on the grand scale of the river. And then these larger straight areas often are widening, and they're becoming more of a fine particulate, almost a fines trap. And really, these areas need changes in flow in order to stir up nutrients, stir up things that have settled down, and to move them downstream. That's what this figure is, and the bottom left of this map is basically based on the river morphology, the amount of time it takes for a particle to settle out. It could be just falling out, and come spring, those peak flows getting resuspended up into the water column. In a lot of these cases, nutrients are actually bound to those sediments, or they're being taken up by primary producers. And we have a seasonal element of the turnover of the nutrient transports moving downstream. So I guess just the point to be made here is that if we look at a place like Cumberland, and then we look all the way downstream to Washington, D.C., there's a lot of just natural sediment and nutrient slowing. I'm going to call them traps for lack of a better term right now, but there are a lot of physical features that slow down the cycling of nutrients from our headwaters to our larger sections of the river. Which brings me to kind of the first point that I want to bring up is, at the headwaters of the Potomac, we have Jennings-Randolph Lake Reservoir on the North Branch. And the Army Corps' operation of this reservoir, they're constantly manipulating flow, everything from artificially varied flows for things like whitewater and recreation to flood control releases. And, to a certain extent, their timing of releases are related to biological targets like fish spawning. So the question is, could the Corps affect an area like Cumberland, where in this last year we've seen there's a pretty high frequency of CSO events, sewer overflows and things like that. Is the Cumberland area acting as a nutrient source? And could the flow, the influence of the Corps on flow affect the downstream travel of those nutrients? And I guess this is my first example. So at this point, I'm going to just talk about this, and then I want to sort of open up the room to any sort of questions or discussions on this first part. But what I'd like to point out is that from our work on a separate project in the North Branch, the reality is the releases of the Jennings-Randolph and the Corps' influence on the North Branch, it's actually reduced the peakiness, the high flow impulses of the North Branch. So it's flattened the highest highs, and it's raised up the lowest lows, and it's actually reduced the flow variability of the North Branch. So the impact of JRL and this idea of, flushing flows is actually something we're investigating right now. ICPRB is investigating right now. But at this time, we don't see things like sediment transport, any sort of scouring effects downstream to Cumberland. We do see some scouring effects proximal to the reservoir itself, but it seems that the flow, the velocity, and its impact on the environment is pretty reduced by the time it gets to Cumberland. Now, Cumberland itself, with all the wastewater discharge overflows issues in this area, it is a nutrient source. But again, I go back to the idea of the river morphology and the releases in JRL combined with the nutrients at Cumberland. When we look at travel time and just a kind of the waveform pulse of detecting that water moving down the Potomac, it takes around 4 days for water to get from JRL to Washington, D.C. But in those 4 days, many of, if not all, of the sediments and nutrients that are in this Cumberland area, they're going through Paw bends. They're going through the fine depositional zones of just above the confluence of the South Branch, the long, straight, flat stretch of Hancock, and again, going through another sinuous section of river above Potomac at Needles, or above Harper's Ferry. And what's interesting about this, and the reason why I brought up river morphology and kind of the idea of residence time and nutrient and sediment turnover, is for the last 35 years, there's been, by many of its names, a Planktonic bloom that's occurred from basically Hancock down to the confluence of the Shenandoah and the Potomac. It's pretty well documented in a recent publication out of Maryland DNR. But the idea of primary producers taking up nutrients and holding on to them for a season until your fall senescence, and getting all the nutrients back up into the water column as they die off, there's this cycle. So I guess the first point that I kind of wanted, or that I would like to make, is to bring up that operations in Jennings Randolph, the Cumberland nutrient sort of point source, if you want to call it that, the idea of there being a lot of nutrients in the Potomac and it affecting DC, there's probably a connection, but it's not one that we would see a signal and a response within the same year. So a spill in Cumberland with a release in, with Jennings Randolph, we're likely not going to see a response in primary production around DC 4 days later. Now, the idea of nutrients being bound into the sediment, and depending on the flow velocity, the year, the precipitation amount on any given year, these abiotic factors resuspending nutrients and moving them downstream, that's something that is going to be off and on every year. So does anybody have any sort of questions as we talk about the headwaters, the North Branch, the western part of the Potomac right now?
Mike, I received a question on the chat. Just a very simple clarification, I think.
Yep.
What do you mean by the word primary, specifically in primary producers? Can you clarify?
Okay. Yeah, so these are just your photosynthetic organisms. Your SAV, that was the first slide. Your submerged aquatic vegetation, filamentous green algae, blue-green algae, your periphyton, things like that. Are there any other questions or anything at this point? One other, then I guess I'll move on. One other thing that I did want to point out, though, just as a kind of a special case in the North Branch, is kind of a question that was asked prior to this meeting, was what's the significance of the invasive golden algae Ditty. And that's a cold water loving species that actually does very well in oligotrophic or low nutrient waters. It exists at the foot of JRL, but it does not extend downstream. And really between temperature and just how fragile it is, it's not really an issue other than very close to the reservoir. So I just wanted to mention that as a side note. Moving on, I want to discuss another example. So we've been working in the Cacapon River. West Virginia DEP started looking at the Cacapon among several other West Virginia rivers starting around 2008 with the focus of identifying nuisance algae blooms, things that impair recreation as well as impact water quality. And the Cacapon stood out as a particularly interesting example. This is one that I could talk on for a very long time. So I suggest if you're interested, reaching out afterwards or after this presentation or checking out some of our publications on the ICPRB page. So the Cacapon River on any given year looks like this picture at a very specific 5-mile stretch. Every year we have problematic nuisance level filamentous green algae blooms, or I'm sorry, in abundance of primary production. So in this particular year, this was in, my notes real quick, this was in 2016. We saw Cladophora basically cover from bank to bank, entire water column, 100% filled with this algae. And when we threw a dissolved oxygen logger at one of these bloom sites, we see these wild deal variation in dissolved oxygen. The continuous dissolved oxygen measure is a good surrogate for total production. And basically it gives us an idea of a stream metabolism. And in this case, we have very low DO periods, and within 12 hours, very high DO. This falls in line with photosynthesis and respiration over the daily cycle. But at these high production sites, this is stressing the biological community. It's indicative of there being excess nutrients in the system. What's interesting is that the year before, this is the exact same site. Now, it might be hard to tell from this picture, but that's actually an invasive submerged aquatic vegetation. That's hydrilla. But similar to in 2016, we see the same large amounts of variability in dissolved oxygen. So again, this site, depending on the year, had an algae problem or it had a SAV problem. No matter what, it's a primary production problem. So all of the key elements, that sunlight, the nutrients getting into the system, and the water flowing past it are all important variables explaining why this is such a high production location in the Cacapon River. Downstream, some 30 miles, there's a USGS gauge from that bloom site, and we still see dissolved oxygen and pH, the two, I guess, water quality measures that we have good continuous data on, that are responding to the respiration photosynthesis cycle. 30 miles downstream, we can still see that the Cacapon River is very productive. Now, it's not as pronounced as what we see at a specific bloom site, but looking at the river as a whole, we can still see this high level of production. And one thing that is interesting that has come out of the Cacapon, however, is over those probably about 8 years or so, looking for an explanation as to why algae is occurring in this reach, we actually discovered that at 1,000 CFS, there seems to be a flow threshold on what, I guess, the flow influences what the dominant species of primary producer in the Cacapon is on any given year. So in 2021, we had a 1,000 CFS event early in summer, and then we dropped down to near drought level for pretty much until September. Because this was a continuous low velocity system for the entire summer, at warm water, low velocity, a lot of sunlight, this led to 2021 being a filamentous algae dominated year. If we go back several years, actually going back to 2018 when there was the really bad flood, submerged aquatic vegetation, primary producers with vascular tissue that can withstand high velocity flow would dominate this system. So the more frequently we cross that 1,000 CFS threshold, the more likely vascular plants are going to dominate this system. The longer we stay in a low flow environment, the more likely filamentous green algae and cyanobacteria, things like that, are going to dominate the system. What's really interesting is there are kind of in-between years where you can have vascular plants build up and then they actually act as like a three-dimensional structure for algae to grow on. So the frequency of these high flow events, as well as the duration and the timing, all play a pretty significant part on explaining what is the dominant species in the Continuum River. The point being, primary production is a better measure to almost think of it as a symptom of a nutrient problem, and things like flow and the type of primary production are clues as to what's going to happen on any given year. So with that, I'm finishing up on the Continuum. Are there any particular questions about the Continuum? All
I
right.
guess actually, is this trend that you've seen with the flow rates giving rise to either filamentous or vascular producers, is that seen in literature and in other water bodies as well?
Yeah, so I guess the idea of there being scour thresholds is something that's in the literature. As to one species being dominant over another, particularly in systems like this, I don't think it's been so closely linked. I haven't found many examples of something as similar as this. And actually, just one other point that I'd like to bring up with the Continuum is that, again, I hate to keep referring to our website and saying, read our research. There's actually a really interesting kind of chemical balance equation going on with the Continuum in particular, and the pH values and the ability to release nutrients based on this overproduction, the fact that we don't have a very strong nutrient signal out there. There actually seems to be a positive feedback loop occurring in the Continuum. But again, that's a whole nother lecture on a pretty interesting process that's occurring out there. So I guess from that, I'm going to keep hopping on forward then. So 2021 was a big year for the North Fork Shenandoah. Just a very quick recap. If you look at the river morphology of both the North Fork and the South Fork Shenandoah, both of these rivers have had an algae problem going back for many, many years. Anecdotally, talking to a lot of the guides, the whitewater community, these two rivers have had blooms for a long time, and actually the state of Virginia has been, I guess, in conversations with the Friends of groups because of the amount of algae that these two water bodies produce. But in particular, the important thing or one of the important things that happened in 2021 that I want to talk about is basically Virginia flagged the North Fork Shenandoah as basically having a harmful algal bloom warning in this area. And what that meant was that things like there was an elevated chance for human contact issues. Basically, if your dog were to drink an area that has these harmful cyanobacteria, potentially toxigenic algae, you could have pets have mortality events, have livestock. There is human contact with skin and gastrointestinal issues that happen. So this area got flagged for a harmful algal bloom, and they actually flagged about 56 miles of the North Fork Shenandoah. You can see in the upper left that there are a handful of points that were actually tested for harmful algae species, and toxigenic algae and toxin values were present. So ICPRB was called in to actually try and get out in a hurry and quantify how much algae was there as a response for the state of Virginia. But as you know, luck would have it, Hurricane Ida hit and came right up basically the Shenandoah Valley. And we had this significant scour event. We were absolutely scrambling to try and get a survey done before this scour event was going to happen. We weren't sure what the path of the hurricane was going to be. Was it going to happen in time? So we had to adjust. And basically, this is a picture of us taking water quality samples down at just above the confluence on the Shenandoah side in West Virginia, the confluence of the main stem Potomac and the Shenandoah. And we just wanted to see, we knew that this was an area that was flagged for HABs. We had measurements of actual toxin loads, intercellular and water column. And we just wanted to know, is this an issue? If this scour happens, are we going to detect these algal toxins downstream? And very briefly, the dilution seemed to take care of any toxins that would have been in the, or could have been in the water column. And we didn't even get algal cells, toxigenic algal cells in any of these grab samples. So in this scour event that broke up these cyanobacterial mats, just in sheer quantity of water, we didn't have a hit. So it seemed like just as sort of a benchmark for future consideration, if we do have a harmful algal bloom in one part of the watershed, if there is going to be a sudden storm like this, we at least have one example that the scouring effects of this high flow will dilute and reduce any sort of HAB effects downstream. So, and does anybody have any questions about that response? Again, this is a really quick summary for a lot more detail into this portion of the project.
Mike, I got something. So this is a question that was given to me in chat. Do you think the extensive Shenandoah River HAB plume observed in 2021, the one you were just referring to, might be typical of prior years, or have we just improved our awareness and monitoring capabilities such that we are now able to document and study such events? Or was the 2021 event unique based on similar monitoring in prior years?
So I know from work that we've done in the Shenandoah in years past that these high production cyanobacteria and filamentous green algae blooms, they've occurred in the North and the South Branch for many years. Now that it's becoming more mainstream, easier to test for. There are labs that work exclusively on algal toxins. We're now able to, take a sample and get it analyzed. So I can't really speak to the previous years in terms of algal toxin loads or anything like that. But I do know, as I mentioned before, from sort of anecdotal interviews with both of those, the North and the South Fork Shenandoah are recreational destinations. It's an absolutely beautiful paddling. And that's why there's a lot of outfitters operating in that area. And a lot of the guides, a lot of the long-term outfitters talk about at the end of every summer, there's a bloom occurring. Now, actual data, it isn't something we've been looking for. So it's only within the last decade that we have sort of we've started building up the quantitative database to start looking at this. But suppose that answers the question?
Yeah, thank you.
Yeah. And then the last thing I want to talk about, so we've kind of worked our way down the length of the Potomac, and then basically there's this last section of the Potomac below Harper's Ferry. There's some interesting things. You know, this is a pretty big area to sort of classify it all as, you know, one bin. But the Potomac River below Harper's Ferry can kind of be broken down into areas where there's very old bedrock, and it's very channelized. There's a lot of mechanical turnover, but because this is just an ancient riverbed, those areas are generally cobble boulder type environments, but then they're sort of interspersed with these, like in this picture, Seneca Pool. And as I pointed out earlier in the slides, this would fall into kind of the classification. This is a fine sediment trap. This is in terms of a depositional zone. A lot of small particles are going to fall out in these areas. And depending on the environment between years, what happens at a site like this could be more similar to what would happen in a lake or a reservoir. And other years, it could be more similar to a flowing river, depending on flow, the availability of water, the water depth. So again, we have this Seneca Pool acting as sort of a depositional zone leading into an area where very channelized, concentrated transport of water, that if this area gets stirred up, there's not a lot of likelihood that there's going to be a lot of things falling out through this area. The rapid elevational change, the substrate type, everything kind of points to this being a very fast transport region. So here you have a sink, and then you have a rapid transport area. And like we've seen elsewhere in the Potomac, high temperatures, low historical flows, and what's nice about some of these downstream gauges, we actually have turbidity. We see that the low flow, the high temperature, there's no shading, or not a lot of shading down at this area, the larger portion of the main stem Potomac. This is really conducive for an algae bloom. So it's not a surprise that we had a bloom in 21 in this area. And what's interesting is as turbidity falls out prior to Ida hitting, that's just clear water that is going to provide a lot of that, photo energy to cause a lot of production. But the point to be made here is that if we look at Little Falls, if we look at Point of Rocks, we look basically up the entire length of the Potomac, and we use dissolved oxygen and pH as a surrogate of primary production, kind of a river's metabolism. We see that the river as a whole is very, it's a very productive river, which means there's a lot of nutrients in this river. It's an enriched system, and that focusing on any one specific algae or SAV as our response, instead of it being a symptom, if we're responding to just a particular type of production anywhere in the Potomac, we're kind of doing a disservice to the bigger picture. So just wanted to throw up what some of the key players were in 2021, but you can see that there are several other algae species, primary producers that occur from year to year, and that really summer 2021 wasn't remarkable in that there was a boom in the Potomac. It just was a favorable environment for, in this case, green algae to really take off towards the late half of July going into August. What's kind of interesting was that one of the dominant algae species at the Great Falls intake was Senodesmus, which is usually used as a bioindicator of good water quality. So here we have an example of a green algae that would generally be a positive sign, but now when the system is out of balance and it takes off, we see that this can become a problem. So this is kind of my summary slide to bring everything in together, but I really want to hit home this long-term perspective. When we look at the, I guess this bloom that's occurred from Hancock down to Harper's Ferry, that's been there for over 35 years, and that's actual state biologists going out and making some note that this has occurred. So we have records of long-term algae problems before we knew to look for them. That also is kind of echoed in anecdotal conversations with what's happened on the Shenandoah. So just something to keep in mind that we just recently started really looking at algae, and we're building up this data set to sort of better understand it. I guess the second thing is there's annual, seasonal, and spatial variability that explains the distribution and the abundance of algae and other primary producers in the river, and that there isn't a nutrient threshold, there isn't a flow threshold for the entire Potomac that is sort of a one-size-fits-all. Basically, it's a case by case as to what the ideal environment is for a particular species, a particular producer each year. One thing I'd like to point out is that not all algae are toxic, but any system out of balance can be harmful. And we can use things, we can use algae as a bioindicator of a system out of balance, but we should treat primary production as a whole as a symptom of a watershed issue, not so much the algae as the issue. And again, just to reiterate the point that the Potomac as a whole is a nutrient-rich system. In 2021, it was a hot, low-flow year, and the conditions around Seneca Pool were ideal for having a long residence time, letting those cells kind of sit and multiply in an area where they were getting ample light and nutrients. And that's just, that boom that we saw in that graph of green algae. It was just perfect conditions for that particular type of algae on this given year. I do think that we will continue to see algae blooms in the Potomac and the Shenandoah for years to come. We can talk about any number of things such as that turnover rate, nutrients and sediments, downstream transport, the influence of groundwater and non-nutrient chemistry, which I didn't get into today. There's a lot of things that are going to have a much longer time scale than a single year. So these annual snapshots are interesting in and of themselves, but need to be put into this long-term perspective. And then finally, there are going to be that this high productivity is something that, if you look at climate models and things like that, we're likely to have more rain and more droughts, is I guess one of the theories that I've heard. And so if we have more summer low flows with a lot of sunlight, we're going to have a lot of production. And if we have a lot of scouring events happening early in the spring, you're getting those nutrients resuspended, you're getting them moving through a system. And as they fall out into depositional zones, this productivity is likely to be a longer term issue than just any single point source spill on any given year. So I guess with that, That's my contact information. I think Claire's on the call with me today. That if anybody has any questions, I would love to talk about it. I warn you, I'll talk your ear off if you give me the chance.
Mike, thank you. This has been so eye-opening. I would like to see if anybody has any questions that they'd like to blurt out. I know some people have been maybe putting things into the chat to the moderators, but does anybody want to ask any questions? And while people think about that, I'll just ask one question about, you know, we occasionally get asked to fill out a form with a very simplistic kind of question. Have you had an algae bloom? And so is there a criteria that you would recommend that a water utility use to answer that question, you know, in the Potomac River? Have we had an algae bloom? How would you answer, and is there a criteria or very specific information on what constitutes a bloom that you use when you're saying there's been a bloom? I mean, is it just the obvious kind of visible plumes that paddlers see, or
So I guess the first way I'd answer that is, what exactly are you looking for? If it's something that you're monitoring and taking water quality samples and have chlorophyll A data, and you can track that it's taking off at an exponential rate or rapidly increasing, that's a quantitative that change in cell abundance would be kind of a something. I don't know of a threshold for that, but that would certainly be a well-supported observation to call something a bloom. The other thing is these algae blooms across the states. You have harmful algal blooms is one definition, which is related to algal toxins. But then in states like West Virginia, and I know EPA Region 3 is working on recreational thresholds for algae. There are spatial thresholds measures where how much of a river is taken up by an algae bloom that can answer that question. So I guess for the drinking water folks, you're not as interested in attached filamentous green algae as you would be kind of a water column bloom. But I guess that simple question of, did you see an algae bloom this year, probably needs to be a little bit more refined as to what exactly is the intended purpose of that question. Do you have anything to add to that, Claire?
Yeah, I was just going to say, I'd like to add to what you're saying. In tidal waters, the Bay program has led efforts, and you're probably familiar with these, to come up with chlorophyll criteria as a surrogate for when algae blooms occur. DC and the James River both have regulations for chlorophyll, have standards and quantitative numeric criteria for chlorophyll. There aren't, as far as I'm aware of, there aren't any for the rivers, the free-flowing rivers, but a general rule of thumb that I think was evolved for the Potomac early on in the 70s was something like, I think between 25 and 50 micrograms chlorophyll is an indicator of blooms. But things are evolving, things are changing. And what Mike said is absolutely right. You need to be very clear what you're measuring, and you need to know more about what your the impacts are. Now in Pennsylvania, they've started using those diel changes in oxygen and pH, and have in the past developed ways of looking at that indicate whether a stream is impaired or not. But again, it's still evolving. So I'll stop there.
had a question that I received by chat. You were talking about the 1000 CFS threshold in the Kakapen for encouraging free-floating versus vascular producers. Is there even anecdotally a number, a flow discharge value that might be a similar or corresponding value for parts of the main stem Potomac, like the Seneca pools?
So that number is something that's going to adjust with every single point on the river. So that there isn't to my knowledge, there isn't a threshold specifically for Seneca Pool or anything like that. Again, I would kind of default to reaching out to Josh Hennessy with Maryland DNR and that 2021 publication, because the reason that they actually started looking at algae blooms in that area was because it was sort of coinciding with smallmouth bass red sites and the really bad years, 2018, where we have a lot of rainfall and a lot of mechanical scouring of the riverbed. We lost pretty significant portions of the smallmouth bass recruitment, the young of the year, because the river got so turned over. And actually the disturbance that would have caused the algae to get ripped up, because it's able to colonize and take sort of advantage after a disturbance event so much quicker than vascular plants and things like that. That algae moving back in is actually was a concern for things beyond just algae issues. It was actually to the sport fish folks as well. So sort of a roundabout way of getting at your question, I do think that there are biological thresholds that we could kind of infer to algae transport and sediment movement, but I don't think there's anything specifically for the Potomac like what we've done in the Kakapen right now.
I can add anecdotal evidence, though. During the 1999 to 2002 drought, the Seneca Pool was chock full of SAV, whereas in other years it becomes this planktonic dominated system. So I believe there probably are thresholds. As Mike says, it changes at every point in the river, but there must be something that is guiding which primary producer becomes dominant in Seneca pools.
I know Claire and I have had several conversations on, you know, that I really feel that the spring timing of scour events in the river really influences what the production's going to be for the year.
Yeah.
And if you have an early summer scour that favors hydrilla, a vascular plant like that, and then there's no other events to scour, that becomes structure, and it's this really complex three-dimensional sponge that just holds the algae, and it actually holds it up into the water column. So that's a scenario where you could have what would normally be benthically associated attached algae growing on top of SAV, and it's basically turned the system into a shallow system again. So it's not the actual hard substrate that's important. In other years, like Claire was saying, in '99, the SAV was able to get to the top of the water column, and it was clear, and it has a lot to do with these periodic events as to which ones take over. It's really pretty remarkable.
There's a question in the chat that's interesting. Somebody has asked whether there are some BMPs that work better in the sinuous sections of the river and others that might be more effective in the straighter sections.
Well, that's a hard one to answer. I don't know.
Yeah, I know the problem is with the scalability of the main stem Potomac. I know with like small little farm creeks and stuff, I know on smaller scales there are BMPs that work, but for the main stem Potomac, that's a much more difficult question. I know one of the things that from our large river work, we go out and we sample an ideal habitat. So we'll go out and we'll kick up in sort of cobble, riffle environments. And that gives us an idea of the bugs that are present to kind of infer on water quality. But because we don't do a lot of sampling in these slugs, these slow depositional zones, we don't even really know the condition of the proximal condition of a lot of these areas. We're just using these kind of ideal habitat, water flowing past a point to infer about the health of a river, of the river as a whole. But yeah, some of those, the depositional zones are certainly an interesting thing worth looking at in the future.
There are more questions. Can we continue to ask them, Claire and Mike? Are you still up for discussion?
Sure.
Two questions here. Are there certain seasonal or flow conditions that would favor toxic versus non-toxic algae? And then, well, I'll save the other one. I'll let you comment on that one.
Well, I can start the conversation. Blue-green algae usually thrive in warm, calm, nutrient-rich environments. And they actually have mechanisms that take advantage of morphology, like they can be attached, they can be planktonic depending on conditions. Planktothrix is a good example of that. When conditions are poor, it forms these resting stages that go down in the sediments and stay there, locked, if you will, to the bottom. And when conditions become favorable, they'll come out into the plankton and float around and form the planktonic. So I started the answer. Mike, do you want to continue?
Yeah. So it's tough to say if any particular one is going to be favored over another. The other, I guess, piece of your question is, to favor a more
Toxicity.
toxic. Yeah, is the issue of a lot of the cyanobacteria, as I guess more and more genetic work is done, there are genetic markers for toxin production, and a lot of these cyanobacterias presumably could produce toxins, and they never have. So there's the question of, does one condition or does one environment favor a toxic versus a non-toxigenic algae? It really is kind of a question of the environment's going to favor one species of primary producer over another, and toxins are really more of a response to a stressed environment. And then to add one more level of complication to it, we don't even really know. There are some cases of high enough like thermal stress that can cause a toxic environment, but in other cases, we don't know why toxins manifest in this large bloom event kind of scenario. So,
Yeah.
What's that?
I was going to say, yes, that's true.
Yeah.
And they're studying it, but they really, it depends actually, I think, on species, what triggers toxicity.
So just to make sure I understand, you're saying that a toxigenic species, whether it does or doesn't actually produce a toxin, depends not only on that specific species and its I guess defense mechanisms, but also the conditions.
Yes.
Yes. Yep.
Another question, and I think this rolls a lot of different thoughts and questions that some of us have based on what you've told us today. Based on our ICPRB's experience, would it be possible to offer a forecast each year, maybe in the spring, of what to expect in terms of algae and producers? So taking into account maybe the CSOs, the weather,
So, I'll take a stab at this, Claire, and you can give me your thoughts. A good example, again, I would kind of default to West Virginia and their development of nuisance algae criteria. There were, oh gosh, I want to say there was 7 initial sites in West Virginia that they were looking at for algae blooms that were, they felt that they had some idea of the predictability of them. And most of them were attached, directly linked to a point source. And that point source, once they treated the wastewater treatment plant that was failing, or they looked at things like golf courses. Once those areas were fixed, the blooms are now gone. That's not to say algae's not there, but the problematic blooms are no longer there. So in terms of finding the point sources and responding, we have a pretty good understanding of it. Now, we get to the little bit more complicated scenario of like the Continuum River, where there's no nutrient signal. There's what we're investigating now is the influence of groundwater and how non-nutrient chemistry is actually kind of fueling what the dominant species at one of these sites are. And we don't even have, I guess, all the variables that that are needed to be a reliable predictor of the bloom at this point. We know areas that we have hypothesis that there are some areas that are going to be higher risk than others. So in terms of an annual forecast, it doesn't really get at that, but we do have an idea across the Potomac. Certain areas seem to be in a Goldilocks zone, be it land use, association with groundwater, non-nutrient chemistry, that they would be more susceptible to blooms. As to predicting a particular bloom on any given year in spring, man, I would love to figure that one out. That's the $1 million question I think most of the algae folks in the US are working on. Is there anything to add, Claire?
Nope, I was going to add that we don't know enough yet to make any kind of prediction with any kind of certainty.
Mm-hmm.
I have one last question that was sent to me. Do you want to ask anything, Renee?
I did have a question, if that's okay. Maybe we could do some follow-ups with them and they can answer it. I have an interesting question that kind of combines 2 source water protection hot spots or hot button issues. We understand that continuous application of algicides like copper sulfate can actually select for cyanobacteria, but intermittent treatment can kill the algae. Do you think the intermittent road salt plays a role in algae ecology in the river by killing beneficial plants and plankton and paving the way for invasive species or the unwanted species?
Mike, do you want to take that?
Yeah, I'll run with it. I feel like I was taking a lot of the first responses I was given. Yeah, so I guess the first thing that comes to mind, there's a lot of topics there. There's a lot of things to cover. But the first being sort of the road salt application and then the algicide application. To me, each of those topics kind of fall into the idea of like disturbance ecology, right? This is an environment that you're rapidly influencing, and then something is, developing after a disturbance. So for things like road salt, if there's something that is very specific, it has a very narrow environment in which it will thrive, and it gets affected if there's no connectivity in the river for that organism to reestablish. Yeah, you've just locally extirpated a potential organism. The other thing I just did to do a parallel, I know some of Fan Hit's work with the specialist versus generalist fish species in the main stem Potomac. We're kind of starting to skew towards a more generalist fish population as more of these disturbance events occur. And, I see no reason why primary producers wouldn't follow the same trend where something that has a wider physiological range of environments is going to thrive more than something that was a particular specialist. So I think that sort of gets at the algae salt question. Was there another piece to that I'm missing, Renee?
No, I think that was it.
Okay.
The last question that I believe I had was about nutrients and the CSOs. I know there's not a way to really quantify the extent to which the CSOs in Western Maryland contribute to the algae that grow, or the producers that grow in the Potomac. But I guess, do you have a feel for whether nutrient removal alone would justify, so like the amount of money invested in CSO correction, to what extent, or maybe how many years would we expect to see an improvement in the nutrient enrichment of the Potomac? Or is it just, too many variables to make a judgment about? Does that make sense?
Yeah, Claire, can I take this one too, since I'm sort of
Yeah, sure. And I'll follow up because I have the Gunston Cove example.
Oh yeah, okay. So kind of working in different areas. One of my other projects right now is I'm pretty focused on the North Branch as a watershed. And one of the things that we have kind of flagged right now is there are both chemical and physical barriers in the North Branch. There are things like the reservoir, low-head dams, things like that, that actually physically stop the movement of things like eels. That has downstream effects through things like freshwater mussels. So as long as things like that are stopping connectivity of a river system, there's a whole downstream ecological impact. When we talk about Cumberland CSOs, just as a chemical barrier, something that is going to be stressing the environment, those CSOs are, in my opinion, it's acting as a kind of a chemical barrier, a threshold to connecting the main stem Potomac to the North Branch, and things like all the things that come with the CSO, not just the nutrients and the downstream primary production, but that area as a whole. Improvements in that area are going to affect a watershed that is rapidly improving as industry has left the watershed, and there are new biological objectives, new restoration efforts happening all through in both West Virginia and Maryland in this area. So to focus just on nutrients and Cumberland is a piece of it, but I would say, again, sort of scale out, and the potential of improvements at that one point has the potential to reconnect and improve a lot of the upstream watershed. So Claire, if you want to.
Yeah, but the thing is, it's going to take time. If you
Yes.
look at the Gunston, you've got a lot of nutrients in the river now, and it's going to take a lot of time for them to either wash out or get incorporated into plant material and stay there. Gunston Cove really shows that. That's the Noman Coal wastewater treatment plant down there, and they started an ecological study in the early 80s that is continuing to this day. And the publications that come out of that show that the cove didn't turn around, didn't recover, didn't start developing healthy beds of SAV and low levels of chlorophyll for years. It took a lot of time for the sediments to lose the nutrients that were stored in there after years and years of wastewater settling in that area. So I think you can expect the same thing up in the Potomac River. And these Planktothrix blooms, even when you've improved the CSO problem at Cumberland and, you know, improved other parts of the watershed, you're still stuck with this legacy nutrients in the river that have to wind their way out of the system.
And I know this is a reoccurring theme. I was did a presentation at the American Fisheries Society earlier this year, and it came up in multiple presentations where the idea of a lot of the low-hanging fruit, a lot of the point source and the immediate proximal biological response to nutrient stressors and things like that. We're good at identifying them and we're good at seeing the immediate results, but we're kind of entering a stage of, you know, the long game, and seeing it's going to take a lot longer for, you know, a distal response from a place like Cumberland to come around for sure. But, you know, it's, to me, I would still say it's worth the effort.
Yeah.
Don't let the long game be a bad thing. It's just a bigger eventual goal.
Great. Now I don't remember what remains of the meeting. I think I'm supposed to call at this point for any further discussion. Are there, does anybody have any new business to bring before the membership here?
Hey, Ann, this is Josh in DC. I've got something that came out recently from the White House regarding cybersecurity for some of the utilities for information. I know that they produced a water sector industrial control system cyber plan. I don't think that was made public. In fact, I'm pretty certain it wasn't made public, but it was released to the states. So if any utilities have questions, I mean, certainly and I don't know if the aqueduct is getting the same messaging that the states are from Region 3, but you know, I would encourage utilities to, you know, reach out to your states if you haven't already, to inquire about the greater cybersecurity task force plan that's being, you know, I guess put out by the White House and then I guess implemented by the EPA.
Good to know, and to know who's got it.
Yeah, I guess if there's any questions from utilities, I'm happy to help answer, you know, if this has been a surprise or, you know, I know that DC Water and others are already participating, you know, in some, you know, critical infrastructure, cybersecurity protections and others, but just, you know, not aware of all the utilities on the call and what their, you know, what their actions have been. So certainly hoping that that the other states and stuff are getting this information, you know, and sharing it as needed.
Great. Any other updates or items to cover today? And if not, I think we can go ahead and adjourn. Thank you all for participating, and thanks especially to our special guest speaker and question answers, Mike and Claire from ICPRB. Thanks to all the work groups who keep us actually productively doing things during the between meetings, and we'll see you all, I hope, at the next quarterly meeting on May 4th.